All right, guys, so we're taking a look at homework number 3, and they tell us that we have a couple of inverse functions, f and g, shown by this diagram here, and they want us to knock out a couple of parts, so let's see. So for part A, so we know that f and g are inverse functions. They undo one another's hard work. So you know that f and g are essentially going to knock out, and f and g are going to knock out. There are no other functions left to deal with. So the original input 88 is going to stay 88. So that's how we get 88 for part A. I got my answer key going up there. How about part B? Let me zoom out a little bit. So let's see. Let's knock out whatever we can knock out. So we know that we have f and g, they knock out. But there is still an extra function f left over, and we must respect it. So that's why this would equal f evaluated at the same number, negative 12.64. So negative 12.64. And now we rely on the diagram. So go to function f, which looks to be the green one, right? Yeah, it's the green one there. So go to the point on the green curve that has an x coordinate of negative 12.64. That happens to be this one here. But now what's the y coordinate or the output? It looks like it says 7. So that's why this whole thing would equal 7 for part B. Now for part C, these are kind of fun, so let me go up here. So let's see what happens. So let's go from the right to the left, inside out. Let's knock these out as couples. So GF, gone, GF, gone, GF, 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 another one, another one, another one, another. Ooh, look, there is a G left over at the end of it all. So that we have to respect it. So we have G, all this becomes, all these are gone, so it just becomes G of 7. And what's G of 7? Where's the picture for G? G is the purple. So G is the purple. So go to the point that has an x coordinate of 7. That's the only point there. And it equals negative 12.64. And that's how they got that value there for part C. Now, how about part D? So let me extend my answer key to go all the way to part E. So for part D, what do we have? We have, let's see, we have G and F knocking out, and then we have another G and F knocking out. So all that's left is 5, but it's multiplied by that coefficient. So that's negative 13 times 5, and that gives us negative 65 for that final result for part D, negative 65. And so now, looking at the last part here for part E, it's an if-then statement. So it says, if that, then what is the value of that? Well, let's take care of this, and that'll conclude this solution video. So let's see. You know what I think would help us for part E, guys, is if we made a really small table. So we can go right here. Check it out. So let's go x f of x, and let's go x g of x, a little baby table. Based on the statement for part E, for table G, if you plug in 23, you get 45 for table G. So here, so if you plug in 23, you get 45. And we know that f and g are inverses. So this point would be switched here in this one. So this input of 45 gives the output of 23. With that in mind, we are able to proceed. Check this out. We're done playing with this. This one piece of information gave us those tables. Now, the goal. What is the value of FGF 45? So f and g are inverses. So this f knocks out this g. All that's left is f of 45. Well, go to function f, denoted by this table. If you plug in 45, you get back 23, which is how they got that as their answer. So if you have any questions, drop them in the comment section below. If not, have a great day, and I'll talk to you next time.